We're on 409.
You said 23? I was wondering why.
I don't remember which ones y'all had. Oh yeah, this was the 2 nights worth.
I understand they like the solutions like split it half.
Yes.
But I don't know why.
Okay. It's gonna be up to you. Some things lend themselves better to others. Let me do 10 comes first, so we'll do that. I felt like we did. I will a lot of times look at what the equation's already solved for. But you need a picture. You're going to have a picture. You're going to have to sketch a picture. That's going to be the easiest way to do it. And you'll see with what we're doing today, a picture is going to save you. Okay. 19 and 20. You could use 19. From 19 on, you could use a calculator. So those are all 15 through 17 are quadratics, right? With just lines. So we know, I always just think about like 15, for instance, is x squared, yes. And this, and I always think about it because, Robert, it takes it from the curve all the way to the axis. So you have to think about what you subtract so you get confused. Parabola opening up but shifted down to 15. She was just asking, I'm not working all the way through, she was just asking, how do you know which one's on top, which one's on bottom? So shifted down to, so it's going to look something like this. And then the line y equals 2, well, that's just a horizontal line like this. So if I look at what's bounded between the two curves, so, right. Yeah. So I would do the integral from, what are these points right here? Negative 2 and 2 for x. Yeah. This is another symmetrical one. They use symmetry a lot. I don't use it as much because I just, yeah, I do. I just prefer to do the whole thing. So I'm going to do top. Top is 2 minus bottom curve. And remember these parentheses because that's what's going to throw you. That's going to give you the wrong answer. So this ends up being from negative 2 to 2. I distribute that through. I got negative x squared plus 4. And then I just do the antiderivative and evaluate. Negative 1/3 x cubed plus 4x from negative 2. Okay. Yes. Thanks for question mark. What 2 outside? This 2? I distribute that negative, so that's a plus 2. So then together they give me the 4. What else? 19 or 21. 19, I think, is a little tougher. I'll do whichever one you want. All right, let's look at 19. 19, I've not seen anything like this in an FRQ, but you would see this in a multiple choice type situation. They love to throw some random variables in there like this. What does, well, this is a calculator, yes. I feel like I was helping somebody with this before we left. It feels like so long ago since we left. I would, because I don't really know what this is going to look like graph the way it is, despite what my A is. I might would put in a random value for a and see what kind of shape I'm looking at. And since it's got to be bigger than 0, and this is a calculator problem, maybe I try just 1. Hey, this one's still in here. Calculator. I tried 4. Wow. And so what this looks like when you graph it is something kind of like this. Something bigger than, and you can kind of play around with it to see what happens if I change, because it's a squared, so if I put in 1 squared is 1, and I graph it, it's the same kind of thing, it's just smaller. As a changes, it looks like it's going out. Like on my calculator, it looks like this is 2, which would make sense. It's going out from my a here. And so if I want to find the area of the region, well, what I probably will use symmetry on this one so I don't have to do 2 separate integrals, right? If I just did from here to here, my top and my bottom curve swap places. So I'd have to do 2 different integrals. But since it's symmetric, I probably would do double from 0 to, well, this was 2. I plugged in 1 and it was 1. Wonder what happens if I plug in 3 for a so that I get 9 minus x squared. I go out to 3 then. So I'm going to say this is my a. Does that make sense? Do you see how I'm reasoning through that? Let me pull my calculator up. Yeah, part of 3 now. Right, so I started out putting in a 1 for a, right? 1 squared is 1, because the equation is a squared. When I graph it, it's kind of hard to see. It goes from -1 to 1. So then whenever I changed a to 2, 2 squared is 4, and I graphed it. That's whenever I started to see a little bit more of what was going on. It's going out to 2 on both sides. Go in and change it even to 3. 3 squared is 9. It's stretching it out more this way, but it's taking it out to that a value. Does that make sense? So I'm going to go from 0 to a for my integral, and I'm just going to double it since this is symmetric on both sides. Does that make sense? And I'm going to do top curve. Actually, there's not 2 curves here to do. I can just do this. But now what do I do? What?
What?
This is my curve, right? That's okay. There's my curve. That integral is finding that. The 2 is going to take this side into account as well. Follow me?
Yeah, I thought you said something about that would.
Okay. You sure? All right. Now I need to find the antiderivative. So this one I'm probably going to use a u substitution. Did we have to solve this all the way? Yeah. What would you let a be? I mean u be?
X squared.
Even more.
A squared minus x squared.
I would do a squared minus x squared. A squared is not going to be a variable like for whatever. It's just going to be right. We're going to treat it like a constant. So du would be -2x dx. I've got the x, but I need a 2 in here, which means I need to counter it with a 1/2 here. Oh. All right, so I have now -0 to a u to the 1/2 du. Is this what y'all did for this one? Or did y'all stop? Antiderivative of u to the 1/2 is what? 2/3 u to the 3/2. And I am evaluating not from a to 0. I've got to plug in those bounds, right? Is this the way I did it whenever I helped y'all Friday? Thursday? All right, I'm going to plug in 0 here, and I get a squared minus 0, which is a squared. I'm going to plug in a here, and I get, if I plug in a squared minus, and I plug in an a for the x, I end up with 0. Does that make sense? This is harder because it's so conceptual with a's. Okay, no, not really. Okay, that's a good question. Now it's higher, so how can I flip that around? Right, and since, remember that negative we countered with out here? Huh? If I plugged in this u equation, and this is coming in, remember whenever we had this negative we had to counter with? It's going to take that, because watch what happens now. 2/3 u to the 3/2, now it's going from a squared to 0. When I plugged in that, because a squared minus x squared, and I'm plugging in for the x, it just ended up whenever I changed my bounds. You didn't have to change your bounds there in terms of u. You could have gone back in and changed your u instead. I just find it easier to. Well, if you change the bounds up, yes. Then you can make it negative. All right, so I end up with 2/3 a squared to the 3/2 minus 2/3. This is one that I definitely think it's easier to adjust the bounds for. Oops, this is good. Which doesn't really matter because it's 0 anyway. So I end up with 2/3. 2 times 3/2 is 3. Please, sweet baby Jesus, see what they got. Yay! What did we do? What else? 25. These are good problems. I know y'all don't like them. Okay, so this is one where you probably were confused about what to do in terms of. Okay, so since I'm having to graph this, I am probably going to solve for y here because I need to graph. And if I've already solved for y, then I'm probably going in terms of x. In other words, this is going to be, oh, wait. I am going to have to do it for x.
Why?
Because if I move that x over, then I have negative x, and then I'm going to have to take a square root of negative x. That's going to give me imaginary. Yeah. So I'm going to have to say x equals negative y squared. And x equals 2 minus 3y squared. Okay, so now I got to think about this. If I graph x equals negative y squared, if you flip that around, but how are you going to graph x equals y squared?
Oh, wait, yeah, you're right.
Did you get the right answer doing that?
Oh my gosh.
Does your back usually do that? You did, Stella? I remember you asking me that, and I remember doing it.
Why can you not just subtract right minus left?
It should still give you the same thing though. If you do this, and then you do this, then you should, because you've got negative x squared, 2 minus, so that's still, it's still down, but it's up. Right. The only difference, it's still going to be the same area, so you can do that. Does that make sense?
Yeah.
Well, unless you're given a picture, it's going to be really hard to graph in terms of y instead of, it's the inverse, so it's flipped on its side essentially. So no, they would give you it would be something like that on its side if you're doing. But the hardest part, the only reason you need a picture is you need to know which one's on the right or which one's on the top, because you need to know which ones to subtract. That's really the only thing you need to figure out. In terms of y, if you're going in terms of y, I almost always, or it's something you could easily figure out. So, well, so this is equation 1, right? And this is equation 2. So if I graph each one of those, and I know what these look like because I'm good with quadratics, right? And transformations. I mean, no, but seriously, it's upside down standard position. It's just the parent flipped upside down. That's this one. This one is upside down. I'm not even worried about shrinks or stretches. It's upside down and shifted up 2. Because remember, my goal is to find out which one's on top and which one's on the bottom. I don't need an accurate picture. I just need enough to know which one's on top. Well, since this one's gone up and this one hasn't, this has got to be my top graph. So now I can do the integral from, and now I need these intersection points. Right? Well, I'm going from top to bottom now. If I left it this way, I would need to know which one is the furthest over. You see what I'm saying? Right. Most of the time. Yeah, but even still, we still converted it over to make it a top minus bottom, right? Because the area is still the same. Whether you're facing this way or this way, that area is still the same. Yeah, and that's what I wanted the area to show. Thursday me was smarter than Monday me.
Well, now we know what we're right.
Say again? What?
I mean, it doesn't matter. I was just saying now we know what one's right.
You do, right. So you could do, but if you do that, remember your bounds are going to have to be with y's instead of x's.
Yeah.
But again, I'm just setting them equal to each other to find that. Where does negative x squared equal 2 minus 3x squared? Add 3x squared. This is happening at negative 1 and 1. I'm finding my bounds because I want to find the intersection points. To find intersection, you find what they share. To find what they share, you find them equal to each other, right? Where are they the same? Looking at me like I'm crazy. Okay, good. So I'm going from negative 1 to 1, and since these are the x values that I'm using here, then I am going to use my top and bottom instead of my left to right. So I said my top was 2 minus 3x squared, 2 minus 3x squared, and from that I'm going to subtract negative x. Yeah, sorry. There's my integral. Looks like Peppa Pig. You never seen Peppa Pig before? No. Okay. Anyway, moving right along. Do y'all need me to evaluate that, or y'all okay? Okay. That's calculator too at this point. Setting it up is 90% of your battle. You said 29? Oh my gosh. This is just calculating. You just have to figure out which one's on top and which one's on bottom. I'm going from negative. Did you do this one by hand? Yeah. Are you in breaking?
I don't know how to do.
Okay, let's do it. Let's do it. Let's do it. Take out your calculator. What, Brian? Oh, you said something. It's awful blurry. Okay. You're not here. You're a figment of my imagination. All right, 8 cosine x. I'm going to bold the second one so we can tell which one's which. You know how to do that? Okay, we'll do it a different color. But remember which one you made what. And I'm going to do 1 over cosine x. Square the whole thing. And before I graph, yeah, good.
Yeah.
I hear y'all clicking. I'm going to set my x window. What? I'm going to set my x's from negative pi over 3 to pi over 3. And I'm going to go ahead and go from negative 1 to 1 on my y's, because that's what you'll generally default to if you do a zoom trig. I think. Because that's the restricted domain here that they gave me. All right, I'm gonna hit graph. Yep. Oh. I'm scared now.
Why did you do negative 1 to 1?
For the y's, well, sine and cosine never go above. Oh, you know what? But it's secant, so it is gonna go. Let's go negative 3 to 3. See what happens. Does it show up now?
Oh wait, yeah.
That's because secant is the one that does this. It goes up from 1 and down from negative 1. Okay, so that's secant squared.
That's all I got.
Okay, hold on. Let me just do it reset.
Oh shoot! Look at that.
That's why we weren't up high enough.
We need to do window. No window.
I'm gonna just change my x then. So I did a zoom trig. Now I'm gonna go negative pi over 3. Pi over 3. I did zoom trig to pick everything up. Now I should see enough. What the heck?
Oh, I got it. Don't change the y value window. Don't change the y window. Or, well, it should be, go make it negative 10. Make y minimum. No, not 0. I guess 0 works.
I literally just looked at it. Okay. Whew. It does look like an eye. I was getting frustrated with mine as well. So which one's on top?
8.
The first one I entered, right? The cosine x. So here's what I'm going to do. I'm going to come out of here. I'm going to go math 7. Nope. 9. Now I need to do top minus bottom. Y1 is top, yes? Bars, Y bars, function Y1. Oops, I need to put a parenthesis around this. Minus Y2. So notice my extra parentheses here because I want it to integrate all of this. Comma X, comma. And if yours is different, just make sure you got this as your argument there. And I'm going from, and they gave me this, negative pi over 3. There's your lower bound to pi over 3, upper bound. You know, this book kills me because clearly they did it by hand if they got 6 root 3. Yeah. But if it's a calculator, I am not doing all that by hand. Yeah. Well, did you do a U substitution on it? Actually, when you subtract them, you have to do it like rationals. You have to find a common denominator because you got 1 over cosine squared and you got cosine. Kind of a hard one by hand. Okay, moving on. Anything else? I hope you're using the calculator to help you on a lot of these. Like, I hope you can do the basic ones by hand, but I hope you're using the calculator for the ones you can use. People who are proficient with your calculator do much better, for sure, because you don't waste time getting bogged down in things that the calculator can do for you. Everybody okay? Y'all need a brain break for just a second before we do these cross sections? Oh, it would be quick. This is fun stuff, though. I like it when we get to this stuff. I'm not sure. Y'all don't know. That, just because I like it doesn't mean y'all like it, though. Okay, you have to you have to be able to think 3-dimensionally to understand this. I know. But if you can't, then I'll just give you the formula and tell you what to do and pull in your chug and you're done, okay? Think about, this is why I really wanted the loaf of bread so that you could see. If you think about a loaf of bread, right, that if I were to graph just the outline of the bread on a piece of graph, right, so it might end up looking something like this. But if I wanted the volume of that bread, looking at only this, I would have to take these slices, or I could take the slices out. I could find the volume of one individual slice, then however many slices I have, right, and add that all together kind of thing. And that's kind of the thought process that we're going through. It's called volume by cross-section. So we're taking these sections out of this 3-dimensional shape, finding its volume, and then finding the entire volume off of that one cross-section. And we're going to use different shapes here. Today we will stick with squares and rectangles because those are easy, right? I don't think it's hard. It's just... All right, so we'll take our cross-sections either perpendicular to the x-axis, which looks something like this. So that means with respect to x, that's the way we always do, right? That's our top minus bottom that we do. Or perpendicular to the y-axis, which means I am with respect to y, and all of a sudden my cross-section turns to look like this. It sounds harder than it is. That's respect to x, yes. Y equals x squared would be respect to x. X equals square root of y would be respect to y. I'm going to give you some steps to follow for this that'll work each and every time, and then I'm going to use those steps to run through an example with you, okay? I'm prepared today. Kind of proud of myself. This is what a cross-section perpendicular to the y-axis would look like. This is what a cross-section perpendicular to the x-axis would look like. This depends on how you slice the bread. Yeah, if I brought loaf bread, it would make a little more sense. Huh? Because I ran late this morning. All right, so directions of these are going to tell you to find a region is bounded by the curves, forms the base of a solid. For the solid, each cross section is perpendicular to whichever axis. What's the volume of the solid? Okay, so how do we address this? How do we tackle it? First thing we're going to do, we're going to say how to. We're going to draw a picture every single time. That will save you because the picture is going to tell you which curve's on top, which one's on bottom. I need to, I'm going to say identify the top or the right curve, depending on what you're taking with respect to, right? Because that's how I'm going to find the area that's bounded between the two curves. Remember the one that we were doing? Like this. So maybe this is my area that I'm finding the volume by cross-section of. And so I'd need to identify that top curve minus the bottom curve so I'd know. Within the problem, it's going to tell you what shape your cross-section is. So I always say to actually draw the cross-section on your picture because it's going to help you see what you need to do. And I know this is going to sound silly as you start doing it, but it will help you. In other words, my cross-section here, if I'm perpendicular to the x-axis, is going to look like this. That's my cross-section. That's my piece of bread that's sliding right out of the middle of the book. Okay. It'll make sense when we pull it together with an example too if you don't. All right, so the next thing I'm going to do is I am going to find the area of my particular cross-section. And this is where it kind of gets hard. It'll tell you what the shape is. Okay, if it says square, the area of a square is right, side times side, right? Or a rectangle, which is length times width, but it'll tell you what that particular area is, okay? So I'll find the area of just one cross section, and I'm finding it in general, right? And to do that, I'm thinking of top curve minus bottom curve for the length there, for how long that is, right? I'm not talking about area right now, I'm just talking about how far apart those are. And to find that, I'm going to subtract the two functions. Okay. So I find the area of my particular cross section, and then what I'm going to do lastly is I am going to integrate. And by integrating, I have found the volume. Of course, I have to find my bounds, right? And in here, I'm going to do the area of my shape, and that's going to give me the volume. Y'all ready to do one? The base of a solid is bounded by the x-axis, and no, this is just an example that maybe I was looking to see that I can't tell where I got it from. Oh, your cross section is perpendicular to the x-axis and is a square. Find the volume. And I'll give you a second to copy this. What does this look like when you graph it? It's a semicircle, actually. And this is a pretty common, this is a semicircle with a radius of A. Okay, every time you see that, that's what that is. It's a semicircle. All right, so if I graph this, because it says that I am bounded by the x-axis and this graph. So I've got this semicircle with radius of 2. Because I just know what the equation of a semicircle looks like. And now you do too. A is the radius, yeah. So if my cross section is perpendicular, it's a terrible semicircle, but you get the point. If my cross section is perpendicular to the x-axis, that means this is my cross section. Do you agree with that? If my cross section is perpendicular to the x-axis, then this is what my cross section looks like.
Oh, yeah, but could it be
Yeah, oh, it could be anywhere. It could be any cross. Could I what? Yeah. You don't yet. You don't. She's talking about the width of the cross section. The slice of bread, just right out of the middle. That's a cross section of the loaf of bread.
Why do we use that?
Because if we want to find the volume of this shape, this is actually a three-dimensional shape. This is just the shape sat down.
That's like the other side.
Right. But now I've got squares. You can order these little things. I'm going to have to see if I can find them. This is just the base, but then you got these squares that are coming up out of it that you can take up. And so I'm trying to find the volume of this shape made up of these square cross sections all put together. Does that make sense? This is just like the stamp of the bottom of it sitting there. Okay. So I've got this square, yes? And if I think about it, okay, all sides are the same. And I'm just pulling this one square out so you can see. This and this will correspond. This will be my cross section. What is that length? Which would be what? How far is it from here to the x-axis? Whatever point we're on, but I want a general. In general, how far is it? No matter where. 4 square root of 4 minus x squared. Does everybody agree? Okay, I graphed. This is 4 minus x squared. Yes, that's what that equation is. And what that tells me is how high to go up from the x-axis everywhere to go. If I'm right here, then this distance is, I plug -1 in there, I get square root of 4 minus -1 squared. That's how far this is. So no matter where I go on here to find this distance, or think, now, some of them will get harder. I'll have to do a top minus a bottom because there'll be some wasted space in between there, right? But for right now, I'm this solid figure sitting on the x-axis. I don't have any wasted space there. So to find out this length, all I need to know is that equation. Does that make sense? Your equation is y is the height, and the height is the width of the cross section. I do, but I'm going to do it in general, and then I'm going to integrate. I just need to know in general what's the height. Y'all okay? All right. So I've got a square, and its side length is the square root of 4 minus x squared. Yes? What did I tell you to do first? Draw a picture. We drew the picture. Draw the cross section. We drew the cross section. I need to know the area of my specific shape. So I've got this square here, right? What's the area of this particular square? 4 minus x squared, because it's side times side, right? So if I do square root squared, the area of just this square is 4 minus x squared. Because the area of a square square or a rectangle, and if it's a rectangle, they'll give you the height. You'll have to link. All right. Now I'm ready to integrate. Now I'm ready to find the volume. So the volume is going to be the integral. What do I need to go from? From negative 2 to 2. That's exactly right. Negative 2 to 2. And then the area of my particular shape. Right. This would be a non-calculator problem. You could do this with symmetry, and you could go from 0 to 2 and double it if you wanted to, or you could go from negative 2 to 2. I tend to go from negative 2 to 2. But if you would rather go from 0 to 2, that's fine too. The convenience, oh no. I exit out of my Miro board. The nice thing about going from 0 to 2 is if one of them is 0 and you're plugging in 0, you just get 0. Y'all go ahead and try to evaluate that integral while my Miro board loads. Tell me what you get. Yeah, you can. Yeah, sure. Yeah. I think I got 32 over 3 when I evaluated. And I'll post this for you guys. I actually uploaded it. I did it on a piece of paper, took a picture and uploaded it. So I'll post that for y'all too. You didn't get that? What'd you get for your antiderivative? And did you do it from negative 2 to 2, or did you do it from 0 to 2 and doubled? Yeah, you get the same thing.
The board. Alright, so basically, find the ring.
Whatever shape they're asking you.
Square the thing they give you?
Because the shape is a square, yes.
Oh yeah, I know that. But
right.
You square it. Or you what? You find it. However you get the area, you do that to it. Right?
Yes.
Take
these are, I didn't staple them together, but take 2 of them. We're not going to do all of them, but I'm going to do one of them with you so you see what happens here. Avery, you need me to finish doing this one?
You would get it in that case.
Yes. minus 8 over 3 would be 24 over 3 minus 8 over 3. Would be 16 over 3.
Oh, okay.
And then you gotta double
I
it.
just made it 8 over 4 and pretended that means it.
Pretend that makes sense. Do y'all want to do one with a hole in it, or do you want to do, when I say hole, I mean some white space? Or do you want to do one with respect to y? Not with a hole in it? Or we could do both.
I never used that.
Yeah. Well, that's your number 5 on the back of the first paper. That's a great one. If y'all are feeling froggy, that is.
I'm feeling a little sorry.
Feeling a little froggy? Madison, these are courtesy of yours, of you. Because I did the book.
Probably like 1.5.
Oh,
Yeah.
I love it when we have like paper.
So this one, they drew the graph for you, which is always nice when that's provided. They're not always quite so nice, but a lot of the harder ones, they will be provided for you. And so this is one that's a little bit harder. You got extra? Thank you. So I've got this graph that's bounded, and I've got this nice little drawing here that looks something like this, but here's my x and y axis. So here's my area. This is the point, they even found this point for me. This is the point E2. That means this is the line y equals 2. This is the line x equals 1. I just like everything to be labeled because it helps me keep up with everything. All right, so we've got to do this 2 ways. Our cross sections are squares, but I need to do it perpendicular to the y-axis and perpendicular to the x-axis. So let's just run through both ways. I'm probably only going to have you practice with one of these tonight. We spent so long. All right, let's do it with respect to x first because I find that to be. All right, so I've drawn a picture. I gotta look at what steps I told you to do. I drew the picture. Let me draw the cross section, right, with the x-axis. So my cross section is from here to here. That's perpendicular to the x-axis. Do you agree? All right. So that is the side length of my square. So my question to you is, what is that value? How do I find what that is? My side of my square. It's going to be top minus bottom, right? I go all the way to the top, and then I take out this. Yes? So it's going to be 2 minus 2 ln x. I didn't label that. To find this green area, I'm going to go, if I do all the way up to 2, well, that gives me this length, right? So I need to take out the white length. Well, what is the white length? The white length is 2 ln x, because that's that curve that it's going up to right here. So if I take the whole thing and subtract out the h hole, then I'll end up with the shaded area. Yes, you do. So now how do you find the area of that square? So, well, the area of the square first would be, that squared, right? So 2 minus 2 log x squared. You would have to FOIL on this one so that you can integrate easier. Well, I picked a hard one to do with you because what do we have? 4 minus 4 log x plus log x squared. What? This is the 4. Yes. Bruh. Yeah. It is, always. All right, so this one,
Why is that? Well,
so to find the area here, or the volume, excuse me, the volume, I'm going to go from what to what? 1 to, look at the picture, E, because I'm using the X values, right? When everybody's going E. Okay, from 1 to E of this monstrosity. I would say that this is definitely, at this point, this is a calculator problem. In which case, we didn't even have to, if we were going to use the calculator, I didn't know if we could or not, because I didn't know what it was going to look like. We could have just left it like this and come down here and put it in just like that. We didn't have to actually FOIL it. If we're going to use the calculator, yeah. 920. Yeah, so in my Y1, put this in Y1. Just like that. Why is it like what? Your calculator's high. I'm sure it's the calculator and not the user. I'm just picking Brian. All right, so I put this in Y1 and then either graph it or go Math 8. Either one you want to do. I usually do Math 8, and I don't know why, because it's or Math 9. Sorry.
That's like what you go back to the main thing.
Mm-hmm. I got 1.746.
no, 1.746.
What are you doing?
Okay, which equation did you put in? Did you square the 4 log x after and not, like, did you put 4 log x in parentheses and then square? You got the same thing? You do. Yes. No, because we've already, I got it written a little different wrong here. Because really, I've already, 2 times 2 is 4. I've already squared that.
Do it the other way, you keep the Y out. And,
But in terms, okay, but, right. But look at this if I go in terms of Y, because I know we're pushed on time. This time, my cross section looks like this. You still didn't get it? Which equation did you put in, Avery? The first one or the FOILed one? When you put the FOILed one in, make sure it's 4 parentheses log x squared.
Not like that.
The log is squared, not the 4 is what I'm getting to. The OG equation. There's both of them the way I put them in. Try it with respect to y-axis while we work on this and see if you get the same. You should get the same answer because it's the same shape, the same volume. You're just doing it a different way. See if you get the same thing. Just make sure you solve the equations for y. I mean for x instead of y. So you get e to the 1/2 y equals.
Write that down?
I did. Because you e both sides. At this point, you e both sides, right?
X equals 1. X equals 1.
Right. So that's already solved for x. So that's your. You see what I'm saying? So a side here, one side of my square is going to be. Do your right one first, right? E to the 1/2 y minus 1. Okay, so your bounds. So your bounds are in terms of y, right? So have that on here. Okay, so my volume is going to be, and I'm going to go on y's, right? So this time this is my cross section, so I'm going from here to here on y. So from 0 up to 2.
But when you type it in the calculator, you replace the y with x.
Mm-hmm.
I didn't like it.
So e to the 1/2 y minus 1.
Oh,
Because it's the area of the square. It's the integral of the area. That's the key to these. It's the integral of the area. And if you can do these, you're going to be a-okay with rotations for sure. Yes, you could. How do you what?
you replace
Yeah. Mm-hmm.